Tate, Department of Civil and Environmental Engineering, University of Windsor, Canada. Professor Liji Philip, Department of Civil Engineering, IIT Madras. Professor Suparna Mukherjee, Head of the Department, Department of Environmental Science and Engineering, IIT Bombay. Dr. Geetha Vani Rasam, Senior Principal Scientist, CSIR Headquarter. Dear colleagues, students, dignitaries, ladies and gentlemen, my name is Dr. Raman Sharma, the Senior Scientist at CSIR NERI Daily Zonal Center. I, on behalf of Director CSIR NERI, Dr. Rakesh Kumar, welcomes you all for this panel discussion on decentralized wastewater treatment, the need of the hour. Friends, as you know that CSIR was founded in the year 1942. In the year 1947, Sir Shanti Swarup Bhatnagar, former Director General CSIR, wrote about the working of CSIR NERI. CSIR. I quote, Sir has written, the scope of work in each laboratory of CSIR could perhaps be best described to be of the form of a continuous spectrum, at one end of which research work of purest academic type and of highest quality is carried out, and at the other, the technical development of processes and equipment proceeds by stages. Walking on the foundation and the path laid by our seniors, our mentors, CSIR is turning 80 in the year 2022. And to celebrate our sincere service to our motherland, CSIR has launched the 80 Years, 80 Success Story campaign. The success story from our sister laboratory, the first in the series of 80 success stories, was showcased on 25th of January this year. Moving forward, keeping in view the importance of World Wetland Day, which is celebrated on 2nd of February every year, and the contribution of CSIR NERI toward environmental research, we have gathered here to talk about CSIR NERI's success story, that is RENEW, in full form, to which we call restoration of Nala with ecological units. And who could be a better person to talk about this technology other than Dr. Atya Kaple ma'am, who is a scientist and head at Director's Research Cell, who has been associated with technology, of course, under the very, very humble, able guidance of our director, CSIR NERI. Now, I would like to invite Dr. Atya Kaple to enlighten us or share about RENEW technology. Over to you, madam.
Thank you, Raman. Good morning to all, and a special welcome to all our esteemed panelists. Just give me a second to share my screen. Can you see it?
We can see it, madam.
Yeah. So thank you once again, Raman. And we are really proud to be contributing into the CSIR success stories. And decentralized wastewater treatment is really the need of the hour. And NERI, being the primary national laboratory with matters related to the environment, has come up with a technology that we took up as a challenge to the Swachh Bharat Abhiyan of looking at the domestic wastewater treatment. So why we actually did this? Because the country does not have the capacity to deal with wastewater generated across our entire region. Most of the water is just pumped or through the drains into the nearest water body, polluting all our rivers and lakes, any water body basically. So the centralized treatment options actually are what is necessary to tackle this problem. When we talk of a centralized treatment, then what you actually mean is that all the wastewater, I'm only talking of domestic wastewater. So all the domestic wastewater generated within our cities, within different communities, within new living spaces that are being developed, is all meant to be channelized and taken into a central treatment facility where it is treated and then released. But looking at the size, the population, the cost, it's not really a feasible option. And hence, decentralized wastewater treatments are really the need of the hour. We are facing really extremely high water stress. You know, we cannot take for granted our drinking water resource to be supplied every day across the country. Some cities are lucky, they get 24/7 water, and some cities, even the metros get water on alternate days. So it's really high time that we actually used wastewater as a resource. Now, this has been used as a, what should I say, buzzword for more than a decade now, wastewater as a resource. But actually taking it into the field is a real big challenge. You know, now, these are some statistics I got from this website, but it is 2011 data, which so I'm sure now it is updated. But you can just see from this picture here that we really, most of our states do not have enough of capacity to treat. Even the most, the ones that we call that are well managed with wastewater have only more than 30%. Nobody has reached up to even 50%. And so we need to come up, once again, I say, with the decentralized treatment options. Now, so what are the challenges that we need to face when we talk of decentralized? The problem with our, management and the scenario in our country is that even if you look at this picture, there is a drain that is meant to be taking the wastewater. But unfortunately, it's also used as a dumping ground for solid waste. So along with that, you have to deal with, managing of solid waste also into your drains. You have different variations in pollution loads. When a drain is made for, say, a community that is taking this wastewater into, I'm sure, the nearest water body, then a new community comes up, a new housing society comes up, and all those channels are attached here. So you have a variation in the pollution level. Any biologist will be able to tell you that, when you're doing a bioremediation, there is a particular concentration up to which a biodegradation process can happen. And you increase that load and the microbes, they go on a back foot. It becomes toxic to them. So we need to also deal with different, variation of the pollution load. Cost is extremely important. We need to have a system that is low in operation and maintenance. And there are, three popular decentralized treatment options that we are following. When I say we, I mean that are popular in India. One is phytoremediation, and the other is microbial bioremediation, and the best option today is constructed wetland system. But each of them, have their different drawbacks. Basically, any biological system needs a certain contact time. So retention time will be very high when you talk of microbial bioremediation. If you talk of phytoremediation, then again, the time is a crucial factor. Harvesting the plants and making sure that they are in a working condition is also something. Biodegradation is a very important process that goes very slowly. So today, the very popular method of use is the constructed wetlands. The drawback here is that it needs a huge amount of space. You can use this kind of a system in places outside the city, but within the urban space, constructed wetlands has its drawbacks. And so NEERI has come up with a combination approach. We have used all the, the engineering tools that STP uses along with our biological remediation parameters. You can see what we do. We make this into a pakka drain, and you can see the workers, they are installing different modules. So we have different modules within this flowing drain. So we don't take up any extra space here, and the water flows. As it flows, it keeps getting treated. So this is our technology called Renew. Like Raman told you, it's the restoration of nalas with ecological units. We had the privilege of actually taking this technology to the field. We implemented it at Prayagraj, which was earlier called Allahabad, just in readiness for the Kumbh Mela of 2019. You can see that the red arrows show you the position of our drains, and this was just opposite to the Kumbh camp, and all the water from these drains was going into the Sangam point, where the which is the actually the holy bathing site for all the pilgrims. And so it was very essential that we treat this water before it can, reach into this join this main drain, which actually leads into the Sangam point. But our journey did not start there. Our journey started with a pilot study at our Niri campus. This is our drone view of our campus, and on the corner you can see where I put this red arrow. This used to be a stormwater drain until the municipality, suddenly one day decided that the nearby localities sewage will go through this, and so it became a normal sewage drain. We started our work here. We incorporated all our different units into this, and we first did a pilot study, which was really nice. And then we wanted to check its performance. So we used, the metagenomic tools. Basically, when you talk of a biodegradation process, it's the biological component that is responsible for carrying out the biodegradation. And so for each of our units, what we did was we got out the DNA sample and we did a metagenome analysis to look at the taxonomy, the function, the stress response, and the basic idea was to add a new dimension, into wastewater treatment. So all the different units that the water flows through during the treatment were analyzed. What we saw was that towards the outlet, we are getting more of an anaerobic bacteria number, the abundance. Actually, we would have preferred it to be higher up in our treatment towards the inlet near the sedimentation tank, because when you have anaerobic bacteria at the outlet, then there is, they give out like a characteristic smell, anaerobic biodegradation. And so because of this data analysis that we did, when we took it to the field, we added a special anaerobic chamber after our sedimentation tank. So that took care of all the foul smell that was being generated, into our Niri Nala. You can see here in this picture. So of course, on the field, it's extremely difficult to make an anaerobic chamber. So we took the next best option and created an anoxic tank. You can see the Ganga bridge there in the background because this is where all these drains go and join in. This project was done under the aegis of the NMCG, and I'm really thankful that they gave us, such important drains right at the Kumbh site to deal with. You can see on the rightmost panel of the picture the color of the treated water. So this water was so clean that the pilgrims who could not afford to go into the camping site and who had made some little camps of their own across the banks here, they were actually starting to use this water. So we had to station a guard there to tell them that this is still drain water, so please not to be used, not to be mistaken. But that was the level of efficiency that we could achieve. What our treatment system does is deals with the floating garbage. Like I told you, this is a serious problem in all our drains. We have screens and traps like this to look at to address that. The suspended solids and the floating matter are settled in the sedimentation tank, and the biodegradation process is happening in 2 stages. Normally the aeration process goes first, but we put the anoxic chamber first because The anaerobic degradation process, it generates lesser amount of sludge than the aeration process. And so we also want the water to be clear of suspended, solids. And so we do biodegradation in an anoxic chamber, and we do solar diffused aeration. So we don't use electricity. We have solar panels that are linked to pumps, and through those, compressors, we leave pipes into the treatment process, and where they create a bubbling. We do a microbial bioremediation by using these flow mats. You can see that they are suspended with wires. We have our immobilized bacterial consortia in a matrix inside this, which we leave into the tank, so that as the water flows, it comes in contact. And it also, this is square, so it acts as another step of filtration, and plus the bacteria, they carry out the bioremediation. And the remaining, the excess nutrients that are basically causing eutrophication are taken care by our flow rafts, where we have these floating, what should I say, rafts with the wetland plants, which also give it an aesthetic look and take care. So this is what Renew is about. This was what the drains looked like when we went to Allahabad, Prayagraj. This is what we converted them into. And it's not just the aesthetics. If you look at the inlet and outlet, you can see a very clear, distinct, improvement of the drain water. Not only was it cleared, it also met all the norms that are required of BOD and COD of suspended solids. All this analysis was not done by us, by a third party. IITR was involved in this project, and they actually measured all our drains. You can see these are the dotted lines show you the efficiency that we have achieved from what were the inlets. We also looked at the degradative potential, the parameters that are measured mostly by the CPCB or anybody measuring wastewater characteristics. They always look at BOD and COD. So the biological component of BOD and COD is actually taken care of by the degradative genes that are present in your treatment system. So we monitored the degradative genes in all the different units, and you can see that we have all the genetic makeup for biodegradation. The peripheral pathways, they are responsible for taking any product, any aromatic compound into the central aromatic pathway, where then it is cleaved and a biodegradation happens. And we also have very good anaerobic degradation represented in our system. The two main nutrients that are there in the sewage are nitrogen and phosphorus, and the excess of these nutrients, they actually cause the eutrophication. So we also monitored these genes in all our treatment units of our Renew. And for nitrogen, you can see that allantoin is one of the major genes that is utilization of allantoin. The gene responsible is one of the major factors. It is associated with nitrogen uptake in root nodules. So we have a phytoremediation system that which is apparently working very well. And similarly, we could map different kinds. I'm not showing you the phosphate. This is just to give you an idea. So that is what our treatment system is about. But since we already had the metagenome data, we also did the presence of the multi-drug resistant genes. And this is something that I would really like to underline. All our wastewater quality is being monitored on the basis of COD, BOD, nitrogen, TSS, but nobody is looking at this, the presence of the multi-drug resistance, the increase of multi-drug resistance in all untreated water, which is going into our natural bodies. This is actually a looming health threat sitting on our heads and really needs to be addressed. You can see from my previous graphs that all the parameters have shown a very good decrease. The efficiency of treatment was really nice. But the multi-drug resistant genes do not show any change in their abundance from the inlet to the outlet. So it is something that, as a scientist and as a scientific institute, we need to create an awareness. This is why I have added this slide actually, to create an awareness that we are overlooking this very important aspect in all our wastewater treatment systems. We need to actually ensure that this is not reaching the natural environment, or we have the next COVID sitting on our heads. This technology got us this very prestigious CSR Technology Award, and this is the team who has worked in it, led by Director Dr. Rakesh Kumar. So actually, this Renew design was conceptualized by him. We actually experimented with it and took it to the field. Ritesh, Hemant, Rita, Tuhin, Sai Saurabh, and some other students from our lab. And we are really very proud that we got this award for work that we could take to the field. So thank you. I will hand it back to Raman now.
Thank you very much, Dr. Atya, for letting us know that why we have gathered here. And I can literally feel the happiness by which you were showing us, telling us about your experiences about Renew. Now, without any further ado, our DG sir has to go. So I consider it a great honor to welcome our very own Director General CSIR sir for his gracious presence. So let us, without any further ado, I welcome Director General CSIR to kindly grace us with his kind words. Over to Director General CSIR.
Thank you, Raman. Mr. Mishra, Professor Seth, Professor Philip, Professor Mukherjee, Dr. Rakesh Kumar, Atya, and all those who have gathered here for this particular event. A very warm welcome to this event. As Raman said in the beginning, we are celebrating CSIR entering the 80th year, starting this September. And we're going to celebrate that year long. And seminars such as this actually go towards the celebration of CSIR's achievement in the society. When we talk of the society in general, all of us know that water, or the treatment of water, domestic water or industrial water, is one of the major issues that we as a country have had to deal with. Several years ago, there were many STPs, they were installed across the country in many different cities, and we immediately found out that the challenges of STPs were, first of all, it was an expensive solution, but also a long-term maintenance of STPs has not been that easy to do, although it's a terrific technology. And that's where some of these concepts, such as constructed wetlands and Renew and all, they came up. And I'm very proud that NIRI has actually taken a lead in implementing some of those technologies across the country. We also requested NIRI, I would like to tell our esteemed panel members and those who are participating outside CSIR, is that we have requested NIRI to implement these technologies across all the CSIR labs. So we have 37 labs around the country, and we have about 50 odd outstations. And under the Eco Campus initiative of CSIR, NIRI is actually going to implement all of these solutions across all the different labs in the country. And once we are able to showcase that, we will then scale up to many other academic campuses, universities, colleges, IITs, ISERs, and all, so that we really showcase that the water can be very effectively reused. The domestic water can be very effectively reused for the purposes that all of us have always thought it should be. Simultaneously, NIRI also has been doing projects such as what Atya just now showed at Prayagraj, and we are very proud of success of these projects. And that essentially highlights the concept of decentralization of wastewater treatment across the different places. I mean, the wastewater thing, the decentralization essentially helps at source to clean up water before it is discharged into either larger water bodies or wherever we use it for any other purposes, like gardening and so on and so forth. And we're very happy that the way NIRI has actually worked on this. As charity begins at home, NIRI first demonstrated the same thing in the NIRI campus itself. Those of you who have a chance to go to NIRI Nagpur campus, They have a very nice installation of this. There's a nala which flows right through the campus, and Niri has demonstrated there that upstream and downstream, there's a lot of difference in the water quality that you actually get to see in this particular place. So all the very best. Look forward to hearing more about this thing. And thank you for contributing to the 80 years of CSI, all of you. Thank you very much.
Thank you very much. So we are truly honored with your gracious presence, and thank you very much. We always look forward to your kind guidance and support, sir. Thanks for being part of this panel discussion. Thanks a lot, sir. Now, with equal pleasure, I would like to request DG NMCG, sir. And we are very, very thankful to your support for this renew system that we were associated with you. And I invite you for your word of wisdom. Over to Director General NMCG Mishra, sir.
Thank you so much. And Dr. Mande, DG CSIR, Dr. Rakesh Kumar, Dr. Kaple, all other distinguished panelists, it's indeed my pleasure and privilege to be with all of you and share some thoughts. As all of you are technically very competent and qualified on this technology, I will primarily try to raise few share some experiences of our mission, that is Ganga rejuvenation, and where we have actually tried to experiment some of this technology. As was very nicely explained by Dr. Kaple about the comparison between centralized and decentralized treatment plants, and we all understand the challenge, and DG CSIR also very rightly said that it's a big social problem. It's a massive national problem how we deal with waste in the city, especially in the urban setting. Of course, even rural waste is also important, but the way we are dealing with our wastewater, especially in the urban setting, is something which is actually highly undesirable, because primarily we do not have either the capacity or the funds, or more importantly the kind of priority that we must dispose of our waste properly and in a very scientific way. So ultimate victim is what? The water bodies, the nalas, the rivers, they become the ultimate victim, and then they carry all these untreated sewage into the river and then create several environmental issues. And we also understand that the problem, I think it was also highlighted, it's not only the huge capital cost. Some of these centralized systems also have very complicated operation and management. They also require huge amount of investment to do, and also good technical manpower. In fact, just to share, when government thought of Namami Gange as a first of its kind integrated project or the mission for rejuvenation of Ganga, not just Ganga, it's a basin approach, so all tributaries, small rivers, everything is part of it. We actually went with a lot of scientific data. A consortium of IITs worked with, and then they had given us a kind of Ganga River Basin Management Plan. NIRI especially, I mean, several CSIR institutions have been involved with us, and NIRI has been a very, very important partner in our journey in this mission. We actually looked at what happened to the previous STPs which were constructed, and more than 50% of them which were constructed over 20-25 years, because as we know, Ganga Action Plan started long time back. They were not actually really functional. I think most of them were defunct, or they were not they were not complying with their standards. And that's why we took a kind of policy. I am going to basically talk a little bit on the policies, because we all understand technically the importance of this technology, and then you people are better to deal with the technology. So I think we took a major policy decision that we will go for long-term operation and maintenance along with the project, and same agency will do it. So that was a major change. And then later on, we'll also made it into the hybrid annuity, where primarily what happens, the investor, the concessionaire will get 60% of his investment in 15-year annuity. So idea is we were trying to improve performance. And we also looked at the various choices, not just the centralized STPs. So that's why when this bioremediation and then the 3 types of decentralized treatment, which was explained by Professor Kaple. So we actually tried to experiment them, and then as was explained, Kumbh 2019 was a major challenge. You know, I think from 2018 we tried to complete several major STPs. And let me tell you, today we are discussing about decentralized STPs. I am quite sure decentralized wastewater treatment. I am quite sure it's nobody case that one kind of approach will solve all the problems. And as was shown in that comparative chart also, in densely populated area, big cities, you will have to go for some of the larger STPs, and they are already there. So I think instead of simply saying that that is not useful and we will go on everything decentralized, I think we will have to have a kind of balance. So I think that's what we have been trying to do. And we tried to actually give a big trial during 2019 Kumbh at Prayagraj, and then we got huge help from NIRI, and then as was explained, NIRI also got a chance to take it out of the lab to the actual field situation, and then it was, it was really very happy situation then, as was explained also, that people were looking at these nalas and then getting such clean water out of it. So many people were thinking that this is even drinkable, which was very, very difficult to, we had to suddenly take a different kind of a step to convince people not to use this water, because still it is the nala water which has been cleaned. So, but Kumbh gave us a very good, perhaps, and then perhaps it will be very good for you to do a kind of scientific research. And then from NMCG, we are actually trying to, because last 3 years, there has been a lot of experimentation, there is a lot of experience. So I think volumes of scientific data has come. All these things will need to taken further. One or two caution or one or two thoughts I would like to share, because I think just now it was being mentioned that we will be experimenting to the various labs. I have seen some IIT campuses also where they have used some of this technology. What is perhaps the most critical thing or most important thing for all of us to think is decentralized wastewater treatment is good, but what happens to the treated water? So I think often that planning is actually having a lot of importance upon collection and treatment, but perhaps we have to give equally important importance for the disposal and reuse. Because often various colonies I have seen, they have actually gone for this kind of treatment, but ultimately what happens, the treated wastewater is again left in the drain. So as you see, the mix is very, very complex in our drains. We have solid waste, we have everything. Like I will tell you in case of Meerut. Now in case of Meerut, we are now working, it's a very, so what happens, there are several decentralized treatment plants, but what is happening, all of them are basically releasing their treated wastewater into a major nala, which is called Abu Nala 1. So all these things going to the Abu Nala, and then finally Abu Nala is meeting the river. And at that point, the terminal STP finds it very difficult to deal with it, because you have got treated water as well as untreated water. So it adds to the complication. And financially also, actually, you have a lot of wastage of resources. And we all talked about precious resources. We really don't have resources. We are only doing, maybe in Ganga Basin, we have improved from 30% to 40-45%. And then next 3-4 years, perhaps we'll be able to improve it further. But perhaps we have to look at this aspect also about how exactly, and perhaps, and it's not impossible. The reuse is very much possible in campuses. So I think when we plan out, perhaps we should actually see that in various labs or IITs or big campuses, we must reuse the entire thing there. Otherwise, if we again bring to the centralized system, perhaps the intended benefit is lost. So that is something which we have to do. In Namami Gange, actually, we have tried to use lots of decentralized treatment plants in Uttarakhand, smaller places. So we have tried to do it. But again, the bigger cities, it's a kind of mix of decentralized and centralized plant. And while we are discussing this, perhaps we also need to keep into consideration a little bit about the septage management also, because all these plants which we are doing, little bit of co-treatment facilities and septage management. So what I'm saying is, basically we need to look at a mix of solutions, and certainly there will be need of doing much more research and much more practical experimentation of all these decentralized wastewater treatment. I will just like to also make some comment about the constructed wetland. I think what NIRI has come up is a very good combination of engineering and biological thing, and constructed wetland is again, we are trying to promote, but I will tell you the problems, because often the state government machinery or the local engineers, they are basically trying to give lot more importance to high cost technology, and we all know the reasons. There are also a problem, constructed wetland, if you want to, perhaps there is need to standardize all these technologies. So like the bigger technology or more conventional technology, there is a standards. So for it's easier and safer perhaps by the public engineers at the field level to go for those things. So though in Namami Gange we are having a technology neutral approach and we don't differentiate, but we are also finding it very difficult to convince people to go for constructed wetland. So perhaps there is need to develop an SOP, there is need to do more hand holding, there is need to do much more capacity building and promote this technology. And then I can tell you with the help of technical knowledge of NIRI and then other IITs, other CSR institutions, and Namami Gange Mission NMCG would be very, very keen to take it further. In fact, we are working with other day I was in IIT Roorkee campus, so they are also trying to develop some SOP on constructed wetland. Just now, I think we had 3-day celebration of World Wetland Day. So I think urban wetlands are very, very important, and there is a lot of need to train people about the way we manage our water and wastewater, and we have to learn to respect water and respect how we deal with wastewater. So I think this is a very, very important occasion to join you people, and then we would be looking forward to further sharing of information. And what we are trying to do is trying to develop a kind of approach where you actually link these things with urban planning. Because as some of you also mentioned that new nalas come, new colonies come, I think that process is irreversible. The urbanization will keep on happening. And what we have achieved today, actually our challenges will not end there. So I think we'll have to continuously work for that and somewhere mainstream all these things into the urban planning and sensitize them. Because without that, it will be very, very difficult for us to be sustainable. So technology, development of technology, nature-based technology, and all these innovative things are very, very welcome thing. With limited resources we have to learn to manage it well and more efficiently and effectively. And then I think together we can actually achieve quite a lot of things at the field level. I once again convey my best wishes to CSIR, the great institution, for the kind of great national contribution it had made. I convey my best wishes. I thank all of you for giving us a chance, and our team will be with you. I will also be with you for some more time, but I have a meeting with Minister after some time, so maybe I will not be able to continue completely, but certainly I will be trying to be with you as much as possible and learn from you. Thank you, all the best.
Thank you, Mr. Ji. It was a pleasure listening to you.
Thank you very much, DG NMCG sir, for being a part of this panel discussion. We are truly honored listening to your practical aspects. You talked about urbanization, which is very much inevitable. And when we talk about urbanization, such kind of nala treatment things are inevitable. We are very, very thankful for talking about the technicality of this particular issue and preparation of SOP, etc. We will look forward to your more suggestions onto this particular thing. Thank you very much once again being a part of this program. Now moving forward, and this is the time I shall be inviting Director CSIR NIRI, Dr. Rakesh Kumar, for sharing his experiences. Sir is working on, be it the phytorite technology, the constructed wetland, be it our renew technology. He has tirelessly worked on these technology. He planted the saplings. Those saplings have become big trees, and those trees are bearing fruits now, and those fruits are now helping the society. And Sir shall be talking about decentralized wastewater treatment challenges from an Indian perspective. Over to Director CSIR NIRI, Sir.
Okay. Thank you, Dr. Raman. I will share my screen and then I'll start. In fact, a lot of good words have been already spoken. So we have to see how I'm able to justify my speaking here. Can you see my slides, Dr. Raman?
We can see your slides. Kindly go ahead, sir.
So what I'll do in next 7-8 minutes is to basically highlight the need and the purpose, the way we are looking at this whole problem of wastewater. So issues before us, as Mishra ji also pointed out and Dr. Mande as well indicated, that one of the issue of use of water precisely is connected with how we are able to segregate them. And as long as we don't segregate them, our treatment schemes become much more difficult. So I'll show you a slide much later that if we segregate certain kind of wastewater, which used to be the common practices in civil engineering earlier, we kind of forgot over a period of time. And if we do that, chances are that our treatment systems can become simpler, and our process of reuse can become much more powerful. The second one, which is conventional end of pipe approach, needs to actually change. This is the time to change for our country to actually use most of this wastewater which is coming out. The third very important issue is upgrading of sewerage system in city with very high investment for government. And if you see the sewerage system, sometimes they are almost costing 60 to 70% of the overall sewage system planning for any cities. So if our sewage systems are not functioning well, meaning if it's not collecting sewage, how is it going to go to the treatment plant and getting treated? So we have to think differently for urban and rural areas, because these are two very different things altogether. And I was very happy to note that DG NMCG pointed that out, that this is going to be a very complex exercise for cities and rural areas to be looked at in a similar fashion. Some of the recent facts and scale that is important to share, that besides the wastewater that we talk about, we generate, as of now, depending upon whatever sewage that we collect, 120,000 tons of fecal sludge per day. And currently we are unable to deal with it. Very small portion of this actually gets treated or managed. About 60% of country's households have no toilets and therefore no connection to sewer systems. Things are improving very drastically, but the sewerage system is something which is very, very complex to implement in our countries where density is very, very high. Cities have been given a sewer system from British time, and wherever we have, by design, sewer systems are supposed to flow by gravity, and after it reaches certain depth, you have to do pumping. So we require a lot of power to do pumping, and sometimes because we are sending all the mixed material in our sewage, which is like all the solids also going into it, most of our sewer system get clogged, and to clean them, we are using workers, and we have seen few thousand deaths every year by way of people going inside the sewer system for cleaning. And therefore mechanization of such cleaning is important, but also one has to see how do we not do this so that the sewage flows into the pipe, not the solids. And then we talk about rural sewers. We are talking about open drains primarily. But and of course, whenever we give solution, typical engineering solution, we say we must have a sewer system as we have in cities. Having not been able to deal with sewer systems of cities, how do we think we will be able to deal with sewer systems of rural area? We need to think differently when it comes to low density population. The silver linings are that in Swachh Bharat mission, the second phase, the announcement of budget which came out, you must have all seen it. It has promised 1.41 lakh crore over a period of 5 years, which is talking about fecal sludge management, wastewater treatment, source segregation and C&D, construction and demolition waste management, and remediation of legacy dump sites. Why it is all linked together here is important to note that solid and liquid waste management has to go hand in hand. If you do it too much of separation, chances are that we are doing one part of the job and another part remains unaddressed or partly addressed. Some of the flagship program which government has done, and many of you may be aware of it, but Swachh Bharat Mission Urban, it initiated Safai Mitra Suraksha Challenge in November 2020, where everyone was invited to give technological solution for cleaning systems so that human intervention in cleaning does not happen. It's being done now in 244 cities. It has actually, the mission has also integrated more than 84,000 informal waste pickers who are working in this area. More than 5.5 lakh sanitation workers welfare scheme has been launched and they have been connected. And the most interesting aspect here is that more than 7 crore citizens have joined in Swachh Manch, which has been created by the government. And this portal is basically to create awareness so that people can address their own issue in the nearby region or wherever they live or wherever they witness something is going on. These are something very, very interesting thing happening. Now let's look at some of the numbers which are very important. When we go for conventional and advanced treatment technology, the normal capex need to be replaced in 3 to 4 years time, because our operational cost varies between 20 to 35%. So when government starts giving funds for setting up sewage treatment plant, it has to also worry about its maintenance, as was pointed out in Namami Gange scheme, that hybrid annuity model has been worked out for 15 years precisely for the operational range. But when we look at these numbers of operational cost, it actually indicates that every 3 to 4 years we have to almost give the whole cost of a new treatment plant. We need to do something by which this operation cost comes down to 5 to 10% range, and that is where challenge of technology and science comes in. And all of us who have gathered today could possibly discuss this today or later sometime. Similarly, when we are putting sewer lines, the current cost is between 2,000 rupees per capita for dense area, where already sewer systems are in place. But wherever we have new areas, it can vary anywhere between 15,000 to 40,000 per person for putting sewer lines. And as you can see, if you multiply by the number of people that we have in our country, these numbers are very staggering numbers. So in place of doing typical deep sewers design, which are conventional CPHU manual based or civil engineering based, can we not think of something called shallow sewer system, which is nothing but a sub-meter, a 1 to 1.5 meter depth based sewer system which flows and which is easy to clean up. So which will bring the operational cost in the range of about 15 to 20% or below. And particularly in sewer systems in villages, it will be able to save a lot of money and it can get cleaned much faster. This all got discussed on constructed wetland. We worked out on phytorate technology for sewage way back about 10-12 years back. Now it's very popular. In situ nala, you heard. We have started doing a lot of work on lake cleanup because most of these water bodies are in deep trouble in terms of the misuse or disuse that we are very used to, and use of river rejuvenation using some of these. Just a few pictures how the phytorate system works. Basically, it is nothing but trickling filter in horizontal form plus plantations which can also take the root system which will clean it up. Now it's advanced enough that we can have complete sensor system so that you don't have to have a person sitting there and running the system in the place. This was shown already by Dr. Atta Kaple. This is something which can be done ex situ as well as in situ. Currently, what was shown to all of us was in situ, but if there is a chance, if there is a possibility, one can also do ex situ. We have also kind of experimented with floating rafters where we put certain kind of plants which effectively take nitrogen and phosphorus and put in the lake, so that over a period of time your nutrients are removed and your algal bloom problems are sorted out. Using that, we created a project last year, and last year it became operational. That Telibandha lake has been now cleaned up using this method, and this was actually implemented through BHEL team at Raipur Smart City project. The other one which we did is Harmu River rejuvenation in Ranchi, where we use the combination of phytorate system to clean up this very small river, but very stormy river when it rains, because it's in the mountainous region and its flow is very high. So here it was all different locations. It was picked up, cleaned, and then water was put inside the river. And now they are using this water for multiple levels because there are areas nearby where they can use it for irrigation purposes. So lastly, few points from knowledge to action is important. The sanitation and employment starts getting linked. It's no more true that we need to have only those people who are so-called Safai Karamchari to be doing this kind of work. There is a possibility, and it looks like there is a distinct possibility that we can get blue-collar jobs by way of doing good quality water recovery and then providing it to people so that people start feeling the benefit of it. Future costs and current expenditure must look at what is sustainable. We looked at some of the numbers, and it indicates that for big cities, centralized system definitely works, as Mr. Raji pointed out, But for smaller places, we need to think alternatives which are much more easier to handle. So this is my last slide and the picture of renewal that we have. That we have to look at decentralized carefully, and as indicated, that we need to have standards. We also need to have SOPs. We need to have so-called DSR rates finalized, so that anyone who wants to design can actually take those rates and bill of quantity, and then make everyone comfortable about this system. The participation of society and technical community is very key, particularly in our country, because unless until we do that, sewage treatment and solid waste treatment will always be in my backyard problem. We have to bring the front system. It has to be in front of us. Then only we'll be able to address. I'll stop here, and thank you for all those who have been able to join and be part of this discussion today. Thank you.
So we are very much thankful to Director CSI NIRI, Dr. Rakesh Kumar, for sharing this wonderful presentation with us. Sir has showed us the good work that CSI NIRI is doing, some kind of a future thing and cost aspects. And so we got so many questions on the social media during your presentation, and people becoming so motivated, they are asking lots of questions. So I will be floating one question to you, which one of the participant has asked. So the person is asking, is it possible to have a separate sewage water from the storm water to save our drinking water lakes or leaking into the earth, effluents sweeping into earth?
Yes, that is possible. The only thing is we can't do retrofitment in the older system. But wherever we have a smaller towns, smaller taluka places, our stormwater should be kept separate than this, where the sewage does not flow into it. And stormwater can actually become a source of fresh water and storage into the lakes and ponds. Yes, it's possible.
Thank you very much, sir. And as the question flow, we will be asking these questions later on. I once again thank you very much for your presentation, sir. Thank you very much. Now, moving forward with our program, I wish to invite Professor Rajesh Seth. I hope Professor Seth has joined.
Yes, I have.
Good evening, sir. How are you, sir?
I'm good. So I miscalculated the time. So I'm looking at the messages, and I thought it was 10 o'clock. So I was missing by half an hour. So
our next speaker has joined. So I will introduce Professor Seth. Professor Seth is in the Department of Civil and Environmental Engineering at University of Windsor, Canada. And he has vast experience of working in the area of water and wastewater treatment. He has worked on ozonation and advanced oxidation processes, microbial contamination, remediation, and contaminate fate during the sewage treatment process, monitoring, modeling, removal. In fact, we were associated with University of Windsor, and Sir was the project leader of that project, where we demonstrated the bubble tube aeration system here at Sonia Vihar Lake. So we have a very strong association with Professor Seth, and he's a very right person to talk about this decentralized wastewater system. And over to you. We very welcome to you for this panel discussion, and we will be truly delighted to have you over here. Over to you, sir.
Okay, so let me make. So is my slide visible now?
Yes, we can see it, sir. Kindly go ahead.
Okay. Okay, so thank you for the warm welcome, Raman, and it's my pleasure to be joining and be in such esteemed company. And one of the advantages of being esteemed company is that everything that you wanted to say has already been spoken. So, but certainly I would like to share a few thoughts. So let me first begin with CSIR celebrating 80 years, and CSIR has immense talent and has made fantastic scientific contributions to the nation. In my opinion, the talent and value is underexploited in what I call as implementation science. So there is a lot of good science that CSIR has done, but what NEED is currently doing in terms of taking the science to the field, I think that there is a lot of value that is not fully utilized. So the problem, as I will try and point out, is not only your science. There are bigger problems, and so we need to simultaneously look at why, apart from having the science, apart from having some of the eminent scientists of the world, why are we having a problem? So centralized collection. So I will not go into a whole lot of detail. So yes, there are many benefits. Yes, there are many success stories, but these success stories are in a very different reality. So is it relevant for India? Other speakers and Dr. Kumar also mentioned about the cost for collection. So there is a huge cost for collection. Up to 90% of the total cost for collection and treatment in a sewer system could be for collection alone. Even higher with existing communities. So how do you put sewers in a city or community that's already developed? Time is a big factor. So we are fighting a losing battle on many fronts, and OM costs and so on. And one of the other bigger problems, which is sometimes missed, is a sewer system puts greater demand on water supply. So you need water. Water is the transport medium in sewers. So in a country where we have already water shortages, making a case for sewer system to push that water is a problem. So decentralized systems. So what are the advantages? Well, all the disadvantages of the centralized systems are the advantages here. But the definition, what is decentralized? Well, so decentralized is somewhere between, so we have large scale centralized, the ones that we are talking about, cities having one treatment plant and so on. On the other end, we have the individual treatment systems like our septic systems. And so we can consider decentralized anywhere in that spectrum. So it could be individualized systems, it could be smaller sort of centralized systems could also fit the bill. The general philosophy is to use what I will call as existing collection infrastructure. So we have our nalas, we have our ponds. So the more we can use what is already there, we don't have to now put a collection infrastructure, and we save on time, we save on cost, and solution can be more rapidly implemented. And also this idea of treating closer to source makes a lot of sense. If you, as much you are able to treat at source, reduce the potential for what we call as diffuse pollution, pollution spreading and contaminating larger bodies of water. So it is not new science. So the philosophy used for decentralized is very similar to centralized treatment. And so science is very similar, science is very sound. So it has been demonstrated. Things that can work, source control. I don't know why septic systems have lost a favor in India. They are good systems, right? So there are a whole slew of solutions. There is no one solution, as Dr. Mishra pointed out as well. So there is a spectrum of solutions that are possible. The Institute in Treatment that is received the award, rightly so, to other systems using existing ponds, building lagoons, for example, using biological treatment processes, anaerobic facultative, aerated, attached growth phytoremediation. Again, a lot of work done by NEED, and all of those make sense. Aeration in particular can be useful. However, it has costs associated with it. So where needed, we can look at providing aeration. when and why provide aeration? Well, aeration improves the kinetics of degradation. So where the time is limited, we want a faster rate of treatment, then we provide aeration. Aeration provides reduces problems of odors, solubilization of metal nutrients, microbial die-off, aquatic life, and all those other benefits. A comment about Atmanirbhar Bharat. So I would certainly like to see a country like my home country, India, to be self-reliant. But my definition of self-reliance is, in a global sense, that's how everybody is doing it, right? So so it does not mean that we need to do everything in India, but the way I see it is we have a priority. We should maximize use of made in India products. If there are unique international products that are useful on a cost benefit analysis, we certainly should look at them, but making sure that there is assured supply and sourcing. Installation, operation, maintenance should be doable by people in India, easy to operate and maintain. And finally, something else that Director Needy also alluded to, we have to make connections. So wastewater treatment, connecting with community engagement and employment opportunities is a needed thing. So again, something that I will not dwell on, but since we are talking about CSIR, this project that I was involved in was a demonstration of an aeration system done in collaboration with CSIR NINI and the Delhi Zonal Laboratory in particular. And so if I'm sharing a few pictures, it is just to make that connection, that if there is something that works well and can be implemented, is the idea here. And by the way, you do see Dr. Sharma in that picture there. Talking about, in the project, we use the bubble tubing. It's a Canadian product. These pumps, which are France, everything else is what one of my students used to call jugaad, right? So we use jugaad to use anything that is possibly available in India to make things work, and we did. Talking about lagoons, they work well, and there is no reason why lagoons or pond treatment should not work in India. They can work in anaerobic, facultative, aerated modes. Combinations can be used. The performance can be enhanced by fixed film growth, something that I'm showing here from a Canadian example, and aeration also can be helpful. So what's the problem? Well, it's a good question, right? So certainly it's not the science. So there is sound science, there is sound talent in India, but still things are not working. So it is important to have these conversations like the conversation that we are having. While we work in finding solutions, we also have to look at, is there something different that we can do? How can we make a difference? Have we thought of everything? Can we involve others? And again, I keep on coming back. There is a very, very important need for community engagement. Connecting people with water is of utmost important. Again, our small efforts with community engagement, and this is not by design. Dr. Sharma, I'm very thankful to DZL and including Dr. Sharma, who helped us do our little project that we did. And one of our objective in a small way that we did was that we want to connect with the young of India. So we went to a few schools. We tried to make that connection with water pollution and the need for treatment. And so the community engagement part is one that I would like to just make a quick comment. Water is a closed loop. And so one water, one health. So if we want to deal with water supply problems, water quality problems, we cannot deal with those problems without looking at wastewater. And so wastewater treatment is an integral part of solving our water crisis. And community engagement, we can start at schools, catch them young. Everybody's responsibility. That message has to be made. Connecting with people with water resources, so they should understand, appreciate, enjoy the value. Demonstration projects. So if there is a demonstration project, if somebody goes to a town or city and sees something beautiful happening, then that's one battle won. So then they can go back and put pressures that they would like to see something similar. Public pressure is in a democracy like India. A public pressure really can work well. Politics, we have to try and get politics out of it. Environment affects everyone. So, and again, public participation would help. And finally, again, create opportunities for local employment. And that's it. I just wanted to share my thoughts. I am glad that I was invited to share my thoughts, and I would like to end there.
Thank you very much, Professor Seth. It's almost midnight. I think half past midnight over there at your place. And we are very thankful for to you for being a part of it. And I was looking into your slides, and some old memories got brushed up, and our association. And we are very thankful to you being a part of it. Thanks for sharing your wonderful thoughts. Thank you very much, sir.
No problem. Thank you, Rajesh. So if you can go and sleep, if there are questions, I'll take and convey it to you later.
Yeah, no, I will stick around. I think yeah, so if I have to go to sleep, I will. Thank you. Yeah.
Thank you.
Thank you very much once again, sir. Now, moving forward with our program, our next speaker is Dr. Liji Philip. Dr. Liji Philip is a professor in the Department of Civil and Environmental Engineering at IIT Madras. And Madam has a vast experience of working in water treatment and rural water supply. And she has also worked in domestic and industrial wastewater treatment with emphasis on wastewater reuse and recycling, bioremediation of contaminated soil, air, and water with heavy metals, pesticides, and other hazardous organic compounds. With such a vast experience and countless publication, we are truly honored to have you today amongst us. Thank you very much, ma'am, for being a part of this program. And Madam shall be talking about the status of decentralized wastewater treatment system in India. I request you to kindly share with us your experience. Over to Professor Liji Philip.
Good morning to all, and thank you very much, Dr. Raman Sharma. I am thankful to the organizers for giving me this opportunity. Our earlier speakers have talked about the advantages of decentralized wastewater treatment systems and all. So mostly I'll be concentrating on the status of decentralized wastewater treatment systems in India. Before going to that one, I'll just talk 1 or 2 minutes about how can we use the decentralized wastewater treatment system for sustainable management of water without even losing a single drop, and also talk about in rural areas how can we separate the rainwater and the wastewater without contaminating the water sources. One of the participants was asking about that one. So as all of us know, decentralized wastewater treatment systems compared to centralized wastewater treatment, they are more sustainable. The reason is reuse is more effective, and people participation will have to be there and will be more in decentralized wastewater. So this can be used for the better monitoring of decentralized wastewater treatment, and we have less problems with underground drainage systems. Okay, they are clogging, repair, operation and maintenance, etc. But small is beautiful, as all of us know, but unit cost will be high. Okay, if you work out the capex.
Professor Liji, your slides are not moving. Are you changing the slides?
Yes. Okay. Is it moving?
No, it's not moving. So can you unshare and share again?
Yeah. One second.
You can use that share arrow button and when you get a red border on your screen, it means it's getting shared.
Is it visible now?
Yes, yes. You can go in the slideshow mode.
Yeah, it is in slideshow mode in my computer.
Okay, but it's not coming here as such.
Okay.
But
Okay.
can you change the slide so that we can tell you whether it's
Moving now?
no.
Okay. I don't know.
So what you can do is keep the presentation open, and when you say share, just take the arrow on the file, and then it will automatically get shared.
Okay. Are you seeing my first slide? I'm not going into the power this presentation mode. Are you able to see my first slide?
Yes.
And is it moving to the second slide?
No. Now yes. Now it is moving.
Okay, so I'll present in this mode. Okay, I think it will be better. Yeah.
Yeah, that's fine.
Yeah. I was talking about the decentralized wastewater treatment system advantages, but if we are not doing it properly, there are problems also. The major problem is not in my backyard syndrome. Nobody wanted to have a wastewater treatment system there, and compromise on quality and compliances. This is happening everywhere. Okay, and if you allow this on, may cause large environmental degradation if not monitored properly. So before going into the status, I will just talk about 2 minutes about the sustainable water management IIT Madras, role of decentralized wastewater treatment. So the basic information, our population is around 15,000 and 3,000 floating population, and projected population is around 20,000, and present water consumption is around 3.2 and projected is 4 million liters, and wastewater generated at this time is around 2.8 MLD. And you know that IIT Madras, okay, Chennai is a water scarce area, and we always have water problem. So what we did is, okay, like any other campus, we have put a state-of-the-art wastewater treatment system, a 4 MLD SBR system. But we thought, okay, because water is so precious for us, so we should not waste a single drop of water from the campus. So what we did is, we have done the tertiary treatment system. Okay, we have ultrafiltration system, ozonation, carbon filter, etc. And the SBR is working on extended aeration process. So we are getting stabilized slides. We are using it for our horticulture purpose. Okay, and what we have done is, we have put dual pipeline system in our entire campus. Not a single toilet is using fresh water. And the quality of water is so good, people are not even able to identify which is the treated wastewater and which is the RO water. And some water we are using for replenishing our pond system, okay, so that, okay, it will be supporting the flora and fauna. And all other water after the tertiary treatment, okay, we are using it for flushing purpose, gardening, and air conditioning, cooling water. Not only that one, still we are left with some water. So what we have done is, after the tertiary treatment, including the activated carbon and ultrafiltration, okay, we have made a filtration well. Okay, so this is around 3 meter deep, okay, sand bed, and you can see that this is the bottom of the filtration well. Okay, and whatever the excess treated wastewater we have, we are trickling through this one, and we are storing in our lake. We have, okay, deepened the lake so that the capacity, the storage capacity is very high. Okay, and we can store huge quantity of water. And the treated water and all the rainwater, whatever is falling on the campus, we are collecting in this lake, and we put up a water treatment system there. Okay, it is having a capacity of 0.8 MLD. So here what we are doing is direct filtration. That means we are adding little bit of alum, then filtration, then activated carbon, adsorption, then chlorination. So that is the treatment we are giving, and we are mixing this water along with the water coming from CMW SSB for our regular purpose. So if you see, we are saving more than 2.5 crore on water bill after taking care of all other expenditure for the wastewater management system. And whenever Chennai city was facing the water scarcity, we never faced water scarcity. And there are so many other intangible benefits. And definitely there was an impact. In Chennai Metro Water and Sewerage Board planning to recycle the water for domestic supply. Already industries are using the recycled water. Okay, they have constructed 2 10 MLD plant. Okay, exactly the same thing what we have done at IIT Madras, and they are planning to put up another 260 MLD recycling system, and we are giving the technical advice. So this is one way we can manage the water, sustainable management of water by employing this decentralized wastewater treatment system. So now coming to the next system, how can we treat or manage the wastewater in peri-urban or rural areas? This is the work we have done in a panchayat just outskirts of Chennai city. The panchayat name is Vichur. We are taking care of around 850 families in that panchayat. So what we have done is, yes, it is a panchayat, they didn't have any drain. So we put the drainage system, and they had a water body. We cleaned the water body so that whatever the rainwater coming, everything will be collected through this drain and goes to the water body. And as we all know, in the peri-urban areas and all, there is no sewer system. So whatever the wastewater generated, except from the toilet, everything comes out, either it is ponding in the roadside or in their premises. So as and when the rain comes, everything will get mixed up and your water bodies are getting contaminated. So what we have done is, we have provided a small bore system. So this will be carrying only settled wastewater, no solid centers here. You can see here the wastewater coming from the bathroom, kitchen, washing basin, or and all comes to a chamber. If any solid is there, it will be getting collected here. And we also collect the septic tank effluent. And after this chamber, it is getting into the small bore system. You can see that one. It is a PVC pipe and it is flowing full. So the cost is very, very minimal. Then what we are doing is, we are taking them to a constructed wetland for the treatment. So as the load increased around 850 families, we didn't have enough space for the constructed wetland. So what we have done is, we have put a septic tank in IMOF type of a septic tank, followed by constructed wetland, which has given very good treatment system, treatment efficiency. So this is the 3-chambered septic tank, and followed by the constructed wetland. I can show you, this is in the field, and this is the performance. Last 4 years it is working, and we are also monitoring all the emerging contaminants, and we could see that the removal efficiency varies between 70 to 95% depending upon the pollutant. So yes, either rural or urban, we can treat the wastewater using the decentralized wastewater treatment system. Now I'll talk about the status. Decentralized wastewater treatment system is not new to our country. This is the data collected in 2015. We could collect the data about 1,517 plants, based upon the secondary information available with pollution control boards and all, based upon the consent of operation. And we collected graph samples from 50 plants, and 15 plants we did elaborate evaluation. And if you see, technology is not a problem. All type of technologies are available in decentralized systems, starting from aerobic filter, DWAS, MBR, EA, ESP, USB. So any technology you mentioned, everything is there. So technology is not the problem, and people are aware of that one. They are implementing, And if you see, okay, so yeah, if you see, okay, the eastern region and northern region, okay, this is the type, number of technologies and okay, the number available based upon various technologies. And this is western region compared to, yeah, western region, the number is higher compared to northern region. And this is the status of eastern region, and this is the status of southern region. Southern region is having, okay, much more number compared to northern region. So, and okay, we have done the evaluation studies and all, and recently we have undertaken another study, okay, to find out the status of decentralized or small scale, okay, treatment systems. This was funded by Gates Foundation, and we did the study in collaboration with EVAN Aquatic Research Center. Okay, because not much data was available, that's why we have undertaken this study. Okay, so we have done elaborate monitoring of 150 units. Okay, for 2 years we did composite sampling, and all the technologies, okay, we have analyzed, and we have done, okay, survey to understand the operation, maintenance, capex, etc. So main conclusion: small scale sewage treatment plants serving between 10 to 1,000 households are existing in large number. There are around 20,000 such systems in operation in India. And we were finding out, are they a viable alternative for centralized system, whether they are cost effective, flexible, whether modular systems are available, what is the technical, financial and environmental performance of the existing small scale, okay, treatment systems, what determines the success or failure of such systems. And if you see, I'm not going into the details, if you see, okay, with respect to biochemical oxygen demand removal, okay, the plants, some are having around 90-95% efficiency, but it is varying between 70 and 95, average around, okay, 80-85% removal efficiency is happening. And when we, okay, that is about organic. When we talk about total nitrogen, the removal efficiency is very, very less, because most of these plants are looking only for organic matter removal. Okay, you can see that total nitrogen removal, except few technologies, okay, others are not able to meet the, okay, standard with respect to total nitrogen and phosphorus. And when it comes to fecal coliform, okay, almost all the plants are having the disinfection system. Much of the plants are not performing well. You can see in the other side of the graph. The reason is your BOD value or organic content coming in the effluent is very high. So whatever the chlorine dose you are adding is not sufficient to, okay, disinfect the water. So this is, okay, the quality. So BOD, COD, TSS, any technology combined with the right tertiary treatment units and operated correctly has the potential to achieve quite stringent standard. No doubt about it. Nutrients, only very few technologies like SBR and MBR are able to meet. Okay, and not talking about constructed wetland. Okay, constructed wetland in some places, okay, they were able to meet the things. And microbial quality of the effluent is consistently not met in almost all the systems analyzed. Disinfection systems not operated properly. High organic content affect the performance. A major issue is the solid management. Majority of the small scale sanitation systems studied do not consistently treat and safely dispose of the sludge they produce. Water reuse practice highlights the good impact of the water reuse policies established over the last decade in the wake of increasing water stress. Reclaimed water from small scale sanitation systems is used commonly for toilet flushing and gardening. Then we also looked into the life cycle cost of for small scale sanitation systems. Okay, a lifespan of 20 years we have taken, and the size we considered here is 40 KLD to 700 KLD. So depending upon the technology we have put, what is the capital cost, 20-year O&M cost, okay, etc. Okay, so you can see, okay, how it is coming. Some technologies O&M cost is very high, other things, okay, it is not that high, etc. But when we talk about the sustainability of these systems, Okay, many places, okay, people were talking about startup and handover. Okay, many places the contractor will construct the plant, but they will not be talking about how the plant is operated, or many times they are not even operating the plant properly before handing over. So that is a very, very major problem. Another one is skills and knowledge of operation and maintenance, personnel and management entities. Operators and managers are often not sufficiently informed about the functioning. Troubleshooting skills are therefore generally weak. Then supervision of O&M activities, operators often are not clearly instructed and supervised. Documentation of O&M activities and financial flows. Okay, it is not documented properly. The absence of systematic documentation and archiving of information leads to loss of knowledge and understanding of the system performance and history. Such data is crucial for decision making and anticipation of maintenance work. Clear responsibilities for organizing spare parts as well as for planning and budgeting scheduled maintenance services are lacking. Because of this one, what is happening is many of the plants are not functioning properly. And policies and institutional factors are another important thing. Lack of a clear policy framework for small-scale sanitation system and overlapping jurisdiction of the concerned agencies hamper planning and implementation process. Coordination between the planning, implementing, and monitoring agencies necessary for better overall functioning of urban wastewater management. Human resources of the responsible agencies have not kept up with rapid expansion of the sector. Mismatch between supply and demand, that is another thing. And monitoring systems are not proper. The pollution control boards have a clear regulatory role to ensure public health and environmental protection objectives, but they are overloaded. Wastewater samples of STPs are currently tested in accredited laboratories, but what we could see is most of the time the samples are often taken by the system owners themselves, sent it to the laboratory, not reliable many times. And many of these plants are having financial issues as a result. Okay, the plants are not getting proper attention, and people try to go for minimum capex, which leads to high OPEX. A more realistic approach to financial sustainability is needed. Okay, not only the minimal capital cost, so entire life cycle cost analysis is needed. And another thing is lack of accountability of designers and consultants of small-scale sanitation systems, which results in low-quality installations and failure in long-term operation of newly built systems. Thank you very much.
Thank you very much, Professor Eligi Philip, for sharing with us your experiences of decentralized wastewater treatment. Madam spoke length and breadth about the technicality of these technologies. She talked about the cost aspects also and various practical things associated with this very important area. It's always a pleasure to listen to you, Madam. Thank you very much for being a part of this panel discussion. Now to moving forward, I would like to invite the next speaker, and the next speaker does not require any introduction. I'm talking about Professor Suparna Mukherjee, who is the head of the department at Department of Environmental Science and Engineering at IIT Bombay. Madam has been awarded with the National Women Bioscientist Award by the DBT. Madam has a vast experience of working in the monitoring of bioaerosols, bioremediation, biotransformation, and toxicity evaluation of complex organic pollutants, characterization and treatment of grey water, development of a treatment scheme for pulp and paper industry, monitoring and removal of micropollutants. So who could be a better speaker for this particular panel discussion today? So I invite Professor Suparna Mukherjee, kindly share with us your valuable thoughts. Over to you, Madam.
Thank you for the introduction. And thank you for inviting me, Dr. Rakesh Kumar, for this panel discussion, and wish a very good morning to all the panelists. So, is my screen visible?
Yes, Madam.
So I think everything I wanted to say is mostly said. So I will just sum up some of the things and touch upon also some things we have been doing on the for greywater treatment. So, as you know, clean water and sanitation is one of the United Nations Sustainable Development Goals. So achieving access to adequate and equitable sanitation and hygiene for all by 2030 is one of the goals, and halving the proportion of untreated wastewater and substantially increasing recycling and safe reuse globally by 2030. Those are the goals. And to do this, decentralized treatment can play a significant role, as we have seen through several of the talks that were presented earlier. Discharge of untreated water contaminates the drinking water sources and also the recreational water bodies and poses a huge risk. So several of our drinking water sources are already have very severe contamination. There is a lot of fecal contamination existing in our drinking water sources, which is of concern. So centralized urban wastewater systems would require the construction and operation of both sewers and wastewater treatment plants. And there is a huge cost associated with the sewerage, as Dr. Rakesh Kumar pointed out. So this cost and also a lot of environmental impacts associated with that would make us should make us think of the decentralized wastewater management systems. So switching to smaller local systems would be a more sustainable solution, and definitely for rural and peri-urban areas, this would make a lot of sense rather than centralized systems. We would have to deal with smaller volumes of wastewater that is generated in a region and handle it in a decentralized manner. There will be greater opportunities for reuse near the source of generation. So some collection system that would be required, of course, but that would be more cost effective than trying to have extensive sewerage network, which is required for typical centralized systems. So sustainable decentralized sanitation should actually be better because it can take into account local hydrology, landscape, and the ecology also. And additionally, if we can separate out the grey water and black water, that can also provide greater reuse opportunities. So moving towards closed loop circular systems will enhance the overall sustainability. And that is one of the prime motivations for looking at decentralized systems where we can enhance the reuse and recycle, as Professor Liji Philip also pointed out, which is being already done in their campus. So that is the sort of thing we need to move towards. So appropriate systems have to be chosen, of course, to see that we get the desired quality of the wastewater that we need. And that can vary depending upon the end use of the water. So typically, in any centralized system, there is a large number of units that are required to remove the various contaminants. In the decentralized system also, we can think of a combination of units, but we can also adapt more eco-friendly and sustainable options so that the overall sustainability of the process is increased. And we have to keep in mind the receiving environment in which we are applying the technology, and also the carrying capacity assessment needs to be done. Other than that, we also have to look at the capacity of the local community to pay for the type of systems that are being planned, because capital and operational and maintenance costs have to be eventually borne by the community. So also we need to think of the robustness and the vulnerabilities associated with the technology and the cost of construction and the operation and maintenance aspects. Another key aspect is, of course, the social acceptance. It is very crucial that it is accepted by the people, so that we have successful implementation of the decentralized treatment systems. And particularly for reuse, we need to have local acceptance. Here we need to have greater awareness, involvement, and participation from the local users. There are some concerns when we talk about reusing recycled water. Some of the concerns are those that center around the health and hygiene. So exposure to the pathogens and hazardous substances is of concern. In most cases, if there is a possibility of contact, then disinfection should be additionally provided as an end process before it is being used. And of course, residual BOD/COD has to be lowered sufficiently so that there is no foul odor upon storage of the treated water before it is recycled. And high TDS can also be of concern, particularly in agricultural applications. So I have put here some of the categories of wastewater reuse and potential constraints in those reuse. So one, of course, is agricultural applications for crops, irrigation of crops, and in also nurseries. So here the concern is the residual salts and the effect they can have on the soil and the crops. Also, public health concerns may be there, particularly if it is being used for food crops, etc. So pathogens in the water like virus, bacteria, protozoa would need to be taken into consideration. And the marketability of the crops and public acceptance is another concern. So for landscape irrigation, here, the water can be reused in parks, schoolyards, freeway medians, greenbelt, and residential applications. Here, one has to worry about the surface and groundwater pollution potential through improper management and the problems of scaling, corrosion, biological growth, and fouling that may be associated with reclaimed wastewater constituents. Industrial usage, when it is used in boiler feed or as cooling water, then there are some public health concerns due to aerosol transmission of pathogenic organisms and also of organics, like volatile organics. For groundwater recharge, there is concern over trace organics in the reclaimed water and the toxicological implications of the trace organics. As you know, certain type of microbial pollutants, even after they are removed, they may be present in the water at a level so that it can be of long-term consequences, both in terms of ecosystem toxicity and also in terms of human health effect if it happens to be present in the drinking water. So recreational and environmental uses, in this case, we have to be looking at the microbial risks, aesthetics and odor, and also eutrophication due to presence of nutrients in the water. For non-potable urban use like firefighting, toilet flushing, etc., we need to look at the pathogen transmission possibility through aerosols, the problem of scaling, corrosion, or biological growth and fouling. For potable reuse, that is direct and indirect, here we need the highest quality water. So treatment has to achieve that level so that public health concerns due to microbes, toxicological effects of trace organic pollutants, etc., these are of concern and this needs to be handled through the appropriate treatment. Now, I'd like to touch upon grey water. So as you know, grey water is water from various sources like bathroom, kitchen, laundry, and wash basin, but excludes the toilet water. In some cases, it also excludes the kitchen water. So a fraction of the wastewater generated in the households and commercial establishments is grey water. It is quite a significant fraction, and it has much less contamination than black water. So a hostel with around 1,000 students would generate about 80 KLD of grey water. This is just to give you an idea of how much is the generation. So in a household, if I assume that 100 liters of water is being used, out of that, the wastewater is about 70 liters would be in the grey water form. And out of this, 48 liters can be reused in the household. So this gives an idea of the scope for reusing grey water if it is managed properly and treated. So to give an idea on the quality comparison between domestic wastewater, grey water, lake, river water. So river water would serve as a, let's say, a source in many reuse applications. So comparing the grey water to the domestic wastewater, we can see that organic load in the grey water is typically, I've given a range that is encountered, but typically it is always much lower than that of domestic wastewater. And one of the other things that we have normally encountered is that the nutrients in grey water is much lower than in domestic wastewater. Both in terms of phosphate, nitrogen, etc., they are much lower in the grey water. And pathogen concentration is also much lower in grey water compared to that in domestic wastewater. Now, when we think of treating the wastewater or grey water for reuse, the immediate thing that comes to mind is, okay, what is the treatment standards that has to be met? And in this regard, we find that the standards are again very country specific. It varies from one country to another. And there is also category of use-based standards. So here I'm showing some category of use-based standards reported by Lee et al. So what you see is that for non-potable grey water use, you see that recreational impoundments, both restricted and unrestricted use, there is difference in the standards that are specified. Some of the standards are similar, but you see that BOD levels for unrestricted use is much lower than for restricted use. And some of the other uses also clearly specifies the difference in the standards. For example, in urban reuse and agricultural irrigation, here also the standards are clearly specified. For urban reuse would include toilet flushing, laundry, air conditioning, usage of water, then landscape irrigation. Here we want the BOD to be less than 10 and turbidity to be less than 2 NTU. Whereas in restricted uses, where there is less access to public, there the treated water can be of a lower quality. Its BOD can be higher, and this sort of differences can be there in the standards. Now, just comparing the CPHO standards with the standards that were reported in the earlier paper that I was citing. So you see that one of the key difference is in the level of coliforms. So the coliform level specified in the CPHO standards is nil. So whereas here it is 10 to the power 4 for total coliforms per 100 ml and 10 to the power 3 for fecal coliforms per 100 ml. So as we already saw that the treatment technology can vary quite a bit. We have seen many examples of treatment technologies that have been discussed today, which are, which have a great potential and are shown to work well. So they can include a combination of physical, chemical, and biological rather than a single treatment technology. So for, in most cases, including biological is required. So only physical for grey water or domestic wastewater would not be adequate. So biological processes like already discussed today, constructed wetlands, microbial remediation through constructed wetlands and other technologies can be very useful. In addition, we can also think of bioreactors like sequencing batch reactors, RBCs, and membrane bioreactors that can help in significant removal of the organic load. And subsequently, this has to be coupled with some treatment for removal of solids downstream. And eventually, it would be necessary for many applications to include a disinfection step also. Now I'm just sharing some experiences with grey water treatment that we had in a novel bioreactor. So our motivation for doing this work was we were earlier looking at some systems that are supplied for treating grey water generated in hostels, etc. Again, extensive systems with lot of units. And eventually we were finding that these units were not working well. Like Professor Philip pointed out, that often maintenance issues are there. Often the operators who are operating the systems are not aware. And this is exactly the type of thing we found in some of the systems we evaluated, that the treated water had so much foaming that the water did not look like a treated water at all. So it was not being, the unit was not being operated properly. This was a sequencing batch reactor that was not being operated as per the proper cycle. And so obviously the treated water was not meeting the quality. So this sort of thing motivated us to try simpler systems without too many units in it. And I'm not disclosing much because we are supposed to try patenting this technology. But anyway, so this is basically a bioreactor. We just did equalization and tried treating grey water in the bioreactor. So we found that we could get good removal of BOD-COD, even when the BOD to COD ratio was less than 0.3 in the grey water. We could achieve good treatment. The water that was treated was of excellent quality, and it had good removal of solids also, along with BOD-COD removal. So TSS turbidity and all were also very low. We had good removal of coliforms and fecal coliforms also. But even after that, so there was 90 to 99% removal was achieved. But even after that, we never got these levels to nil. So it is important that if we have to meet the standards specified in CPHO, then it is essential to have some disinfection associated with that. Another thing that was really affecting the process, which we found, is that the inlet had huge fluctuations. Again, this is grey water taken from hostels, both in IIT and elsewhere. So we have tried in a separate place also in Gujarat. So what we found is that the inlet grey water has very large fluctuations, and that was hindering the, our treatment efficiency remained high, but the actual values of BOD-COD were going up in the effluent when there was high influent concentration. So equalization is one of the most important things that needs to be done to ensure that we need a fixed standard at the outlet. So this was another thing that we felt based on the studies that we did in this system. So the challenges for reuse would be to minimize the variability that we are observing in the grey water, and to understand the operating conditions that can provide adequate treatment. We were using quite a long HRT, so optimizing that HRT would be a thing to do that would improve, make it more effective in the long run. And again, we need to study biokinetics in the system. That is yet to be done. And so one of the other things that we encountered is in grey water, often we are finding a scenario where the phosphate is too low. It is so low that it is inhibiting the removal of COD, BOD and COD, unless we supplement with phosphate. So this was another thing. So, but this sort of a limitation will never be there in sewage. This is particular to grey water. And that zero fecal coliform norm we cannot achieve without disinfection. So we really need to look at novel processes and their potential to explore for reuse of treated grey water or reuse of treated wastewater. It's very important to explore novel processes and see how we can reuse. We can also look at application-specific standards for reuse rather than trying to get to a very good level. We can look at what is needed for a certain application and then bring it to that level. That would be a much more cost-effective way of reusing the treated water. Thank you.
Well, thank you very much, Professor Mukherjee, for sharing with us your experience about novel bioreactor. And Madam, I very much like your simple thoughts. You said that it's very simple for us to say that to separate the grey water and the storm water. I think it's very much required. It has to be a part of our town planning now. And I like your point that capacity of the community to pay during the operation and maintenance. It is very, very important aspect. I think we construct swanky these wastewater treatment plants, but due to that insufficient funds, we are unable to run these white horses. And also most important thing that you mentioned is the social acceptance. Ma'am, we are truly honored with your thoughts, and thank you very much once again for being a part of this panel discussion. And thank you very much, ma'am.
Thank you, Suparna.
Thanks.
And now before moving forward, sir, with your permission, can we take a few questions?
Yeah, I think we should take, since we're calling it a panel discussion, we should take some questions, and then we'll request Dr. Geeta to close as we go ahead.
So the first question that we are receiving on the social media platform, it's what is the cost per meter of treatment? I think this one is referring to the renew system. Ate ma'am, this is for you. What is the cost per meter of treatment?
It has to be per meter cube, I guess.
Yes,
not meter.
Yeah, I think maybe sir will only answer this because treatment cost varies with flow, with location, with so many things. So what we did at Prayagraj, was per MLD. So because of that region, in Niri we had a different cost, in Prayagraj we had a different cost. So maybe sir would make a generalized statement.
Okay, it actually varies anywhere between say 0.1 paisa to 1.5 paisa per liter. So the person who is asked question can multiply for meter cube. 1,000 liter is 1 meter cube.
Thank you, sir. And I move on to the next question. It says that, do we have a cost benefit analysis and failure analysis of decentralized wastewater treatment plants?
I think that's what Professor Liji Philip has done. If she would want to make any comment on that. Liji, are you there?
Yeah, I'm here. Okay, we have done extensive cost benefit analysis and failure analysis. Okay, and we have submitted the report to even our CPHEO. Okay, and it is there in the EVAT website also. So, okay, so I have shown a slide on that one. Okay, it is varying depending upon the technology. So some places the capex is very, very less, but the opex is going very, very high. And you can see that 20 years opex, you take it, okay, it will be almost 10 times the capex what we are putting as when we talk about the decentralized system. Okay, we have put up that report in open. Okay, so it is accessible. Yeah.
Okay, Professor Seth, would you like to comment on this? Your Canadian experience?
Well, I don't think so. The failure rate, it really is the operation and maintenance of these systems. It's really a big part, and I think something that I was thinking through was the fact that we make decisions based on capital cost, operation and maintenance, and I have heard that one in every talk. I think in terms of identifying a problem is somebody has to pay, and operation and maintenance and costs, we do project after project, and so operation and maintenance cost has to be taken into consideration, ownership has to be taken, and it's part of the equation. But beyond that, most of these systems, there is really no moving parts, right? So if they are maintained properly, there is no reason why such systems should not work. So I think we see in, so for example, here for stormwater management ponds, when they are looking at quality improvement, it's a huge cost. So it has to be, so when you settle solids, then solids removal and management, so whether even it's a renew system, so if the water is getting clean, then those solids are going somewhere, right?
Yeah,
so
correct.
Yeah, so the operation, maintenance, and disposal of the solids, I think but failure should not happen if there is proper maintenance.
I think the failure analysis is more to link with the way we do maintenance, and therefore it's a very broad question. So when we're talking about, we should be talking about 10 to 15 years of life cycle working, as well as the cost related to that. So if you don't maintain well, your operation cost suddenly on fifth year will go 3 times, 5 times, or you don't know what exactly it is. But if it's properly maintained, one can actually keep a very low maintenance cost. Absolutely. Yeah. Raman, are you still there?
Yes. Yeah. And the next question is, I think it's a very general question. In decentralized wastewater treatment, to remove BOD, COD, and TDS reduction, any technology available in India? It's a very generic question.
So I think we don't need to answer all these questions. All these technologies do that. Yeah.
Definitely.
For TDS, we separately need RO kind of technology, but rest of it will deal with BOD, COD, and all.
Sir, next is, what is the percentage of sediments in wastewater? All the plants never tolerate high concentration of BOD, COD, and TDS. They will die. Yes or no?
So all this constructed wetland related work that has been done, and I'll also seek opinion of other panelists. They do not die in the range of BOD, COD, and TDS encountered in sewage. But if you want to use it for, say, industrial wastewater of various origin, one cannot say that. It's very difficult. Any comments from other panelists if they want to add?
Say when the BOD or COD value is very high, okay, if you directly go for constructed wetland, the area needed will be very high. So another option we have is, okay, you put a septic tank, okay, 2 or 3 chamber septic tank. That will take care of around 50 to 70% of your organic load. Then if you send it to the constructed wetland, it is meeting the latest guideline values. Okay, so many ways we'll be able to tackle this type of wastewater. Some pre-treatment if you can provide, then that one will be increasing the efficiency.
Right. So I move to the next question. As the urban wetlands are found to be potential structure for nature-based wastewater treatment, do we have any national program running to harness urban wetlands for wastewater treatment?
It's a little loaded question. So urban wetlands are not supposed to be suddenly made into wastewater treatment plants. So wetlands, they need to remain wetlands. But yes, if you are making our own so-called man-made wetlands for treatment of wastewater, they will be additional to the normal wetlands. So by making existing wetlands into treatment plants, it will create a lot of furor, and NGOs and all that, they'll wake up. So we should not try doing that.
I think that's it. I can see on the social media platforms. I think we have addressed most of the questions that we have received. I think that's it from the social media platform, sir.
So I had one small questions to two panelists here. One to Professor Seth regarding concern about this so-called resistant bacteria. Anything happening in Canadian coast, and how do you deal with cold water, cold climate, wastewater treatment plant, particularly this wetland or pond system, oxidation pond system?
Yeah, so I liked Arthur's comment. Actually, I could have shared a slide of what an ESBL E. coli looks like from personal experience. So I came down with an infection of ESBL E. coli, and it is scary. So antibiotic resistant of organisms is a big problem. Microbial pollution is a big problem. So I don't think so it is being addressed in any way here. It is just that because we have less of an issue, but it is becoming a global problem. In India, it tends to be a little bit more because of widespread use of the antibiotics. But I don't know that's a challenge in itself.
Okay.
The antibiotic.
And what about a cold climate?
Yeah. So
oxidation bonds. Any opinion?
Yeah. So cold climate they work. It's really a combination of retention time. There is all those concepts. There are various concepts that are used, right? Like, so there are lagoons that have aerobic, anaerobic, facultative, aerobic. A lot of them have long retention times. They're seasonal discharges lagoons, so they have some are 6 months storage and so on. And for colder climate, when they were looking at nitrification, they are being enhanced by providing fixed film, and so fixed film seems to work. So they are even able to get nitrification at temperatures of 4 degrees C. So lagoon systems in combination with or without aeration can really be quite effective. Yeah.
Right. Thank you, Rajesh. So I had feedback separately for me. So one last question, and then I'll ask Geeta to close. Professor Mukherjee was talking about grey water, work that's very neat work, but the deficiency of phosphorus and to use biological system to add phosphorus to make it work. Can we not use normal physical methods? Someone just texted me. So Professor Suparna Mukherjee, could you respond to this?
So what we found is that in some cases the BOD is very high. So as I was telling you about the fluctuations, so this type of a water, if you try with only physical treatment, it will not be a good idea. So biological treatment was very effective in BOD removal, but only thing is some phosphorus addition at some points were needed. So what we were finding, we were monitoring that ratio, and in some cases when we were not adding and the ratio was not adequate, we found that the COD removal was getting affected by it. So some phosphorus addition can get rid of it.
Right. Thank you for clarification, because I got 2 texts on this. Thank you. So done from our side on question answer, Raman, and so we can request Dr. Geeta now.
All right, sir.
Thank you everyone from my side for participating.
So thanks once again all the panelists for answering the questions posted on various social media platforms. So friends, we have almost reached at the end of today's panel discussion, and before closing, I would like to request Senior Principal Scientist from CSI Headquarters, our colleague, Dr. Geeta Vanirasa, Madam, to kindly present the vote of thanks. Over to you, Madam.
Yeah, thank you, Raman. It was really great listening to all of you today, and it's a very good experience to know about wastewater treatment. And I think I can't think of any other better topic or more important topic than this, I think, in today's situation. It was really emphasized by all the speakers on the need for it and what are the various options available, and how do we go about it. And as Dr. Mande mentioned in the beginning, this is a part of the series which we plan to do every week, highlight one aspect or one successful technology, or it could be a knowledge base or any contribution of CSIR. So over the next 80 weeks, our idea is to highlight one particular aspect. And today, as you all have seen, we are talking about the wastewater treatment technologies, be it the Renew or the Phytoroid. And so I think we continue this format, and I really thank Dr. Rakesh Kumar Niri, Director, for taking the lead and inviting everybody and putting together this whole program at a short notice. And of course, I would like to thank DGCSI, Dr. Mande, who's been the force behind all this science communication activities which CSIR is engaged in. Without his support, we would not be able to do all this. And also would like to thank Mr. Rajiv Ranjan Mishra, who really graced this occasion today to highlight the importance of this. And also thanks to all the other speakers, Dr. Rajesh Said, Professor Philip, Professor Suparna Mukherjee, Dr. Atya, Dr. Raman, and everybody over here and joining us and listening to this technology. I think this is a very important part. I think we do technology, but dissemination of this technology, both for adoption by other people and also knowledge about this technology and, about this communicating the importance of this is a very important aspect, which is often neglected. I think we make the technology and maybe we hand it over to one or two people and we think our job is done. But I think this kind of dialogue, especially with the government ministries and with all the stakeholders, including the public, is very important because every small thing can make a difference. So apart from highlighting the success, I think this dialogue is also to increase the awareness of various technologies such as this wastewater treatment. And I hope you all enjoyed this session as much as I did. And last, I would like to thank our team at headquarters, Mahesh, Shika, and Deepak, who also have helped us in putting together this event. And thank you all. And do keep tuning in to our various success stories and various initiatives as we move forward.
Right. So thank you very much all over again. See you again.
Thank you, everybody.
Okay.
Thank you so much.